Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Liao, the online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Jiali Liao from Bio-Rad Laboratories.
Welcome to the webinar. In this presentation, I would like to introduce a new anion exchange chromatography resin we developed recently, which are specifically designed for large biomolecule and for the purification and downstream capture in the downstream processing. And the topic we are going to talk on this presentation will be including what is the challenge for large biomolecule, and I would like to introduce the Nuvia HPQ, how the Nuvia HPQ was designed and how it works, and what is the technical feature, and finally I will show you some application on the large biomolecule purification. In general, challenge, as you know, when the molecular weight becomes so big, like the virus, particle, IgM or IgA, the diffusion coefficient is very slow, and therefore the mass transfer chelatity is a big problem. Especially currently, the resin available in the market have a lot of limitation. For example, maybe the pore size, some of the pore size is small, some maybe the pore size is big, but the surface area, the binding size is small. And therefore, most of this resin have very low binding capacity for this large biomolecule. On a specific challenge, for example, the IVIG, which often have a large sample volume, and because they are plasmid samples, sometimes they are very viscous, and therefore the challenge is to run in high flow rate, meanwhile still have high binding capacity. For the IgM, the main problem, as we mentioned, the molecular weight is so big, and therefore the diffusion coefficient is very low, and especially unlike IgA, you are able to use protein A for the purification, so there's no affinity resin available for IgM, and virus particle is even more difficult to handle on the downstream processing, because such large molecule, if the pore size is not big enough, they're only able to use the surface for the binding and capture. And if you have a large pore size, sometimes they are physically trapped inside the pore, so the challenge will be the recovery. Nuvia HPQ is based on the UNOsphere technology. We have been developed this resin for many years, and as you can see from the SCM, the particle size is very uniform. It's around 15 micron. Especially when you look at the surface structure of the pore side, they are high porosity with very large pore. Unlike most of the polymer-based resin, they often have a shelf on the surface, and the large molecule cannot penetrate through the shelf. They have to penetrate through the pore. But as you can see, the Nuvia HPQ, the porosity is very high, so everywhere the biomolecule is able to penetrate and bind into the resin. And as I mentioned, the Nuvia HPQ, the base piece, have a large pore, which is easy for large biomolecule to penetrate. And we also optimize the graft technology to increase the binding capacity, as you can see on the slide. So the graft technology has offer a lot of binding size. Meanwhile, they are large. The pores still large enough. They are not eliminate the mass transfer or the diffusion for the large biomolecule. The feature of Nuvia HPQ, as I mentioned, they are very rich. These are very rigid beads which you are able to run high flow rate, and together with the large pore structure, so you are able to use it for fast mass transfer, and combined together, you are able to increase the high binding capacity, high flow rate, and then improve your productivity. And the resin is quite stable. We will later show you the cycling study, which showing there are almost no loss in dynamic binding capacity during the 100 cycle study. Since as I mentioned, we have already optimized the pore size and grafted the ligand technology, we are able to improve the binding capacity and mass transfer kinetic. And meanwhile, because the bead is rigid, we are able to make it as a 15 micron bead, and that helps for the fast mass transfer for the large biomolecule into the bead. The resin have very low non-specific binding because the UNOsphere Nuvia technology, we start with the water-soluble monomer. Therefore, the resin, after the polymer, the matrix monomer is very hydrophilic, and the non-specific absorption is very limited. And the rigidity was studied in a large pack column, and these are the 20 by 20 centimeter column. And as you can see, between 0 to 400 centimeter per hour, the bed have no compression, and the pressure flow curve is linear, which indicate that the base piece is very rigid. And even over 400 centimeters per hour, there's only very limited compression. And we also compare the binding capacity on the large biomolecule. For example, Thyroglobulin have very large molecular weight, and we compare the chromatography resin available in the market for biomolecule purification. For example, some of them is a dextran base, some of them is polystyrene base, and methacrylate base. And as you can see, Nuvia HPQ have the best binding capacity. We test different residence time, 1.2 minute residence time and 2.4 minute residence time. In every course, the different residence time, the Nuvia HPQ have the highest binding capacity. The cycling study, we use in between the binding study, we use 0.5 molar sodium hydroxide for the sanitization, and use it and hold it for 40 minutes. And during with this course, the 100 cycle study, we can see the binding capacities remain unchanged or limited change, and the recovery is still unchanged. So that indicates the resin is very stable, and you are able to use 0.5 molar sodium hydroxide for sanitization. Since we developed this resin, we have been sent out for customer to evaluate and to use in different applications. For example, the large biomolecule and wireless particle, pacular protein, and also the DNA purification. In the next few slides, I will show you some application which we are able to get the feedback from the customer. For example, there's a customer who want to use our HPQ for the IVIG purification process. That's one of the IVIG purification process step is to remove IgA and IgM, and as they also compare with other competitor resin, for example, the dextran-based beads, agarose, polystyrene beads, and compare with the Nuvia HPQ. As you can see, the Nuvia HPQ have the highest binding capacity. The dextran-based beads, this resin also was designed for large biomolecule purification, and they have also binding capacity is very similar to HPQ, Nuvia HPQ, except the rigidity is low. Therefore, they cannot use high flow rate in their processing. And agarose-based beads is rigid, and it's well known agarose beads is used for size exclusion chromatography. Therefore, you can imagine the pore is relatively small. So when you handling the large molecule like the IgM, the binding capacity is very limited because the pore is so small. And styrene divinyl benzene, you often have a large pore, but the problem is the polystyrene divinyl benzene resin itself is very hydrophobic. So although they have been coated with a hydrophilic polymer, but it also behaves like some kind of mixed mold, and the recovery sometimes is very low. So the customer consider the performance is low. Polymethylacrylate beads is also an chromatography resin in the market, which often have also large pore, but the surface area is limited. Therefore, even the pore size is big, but the porosity and combined with the smaller surface area, which cause the binding capacity drop. And as you can see here, the customer also evaluate the fibrinogen on the binding capacity study. Fibrinogen, although the molecular weight is not that big, but the rock-shaped structure where the length of the protein is almost like 460 angstrom, is like 3 or 4 times large than the diameter of IgG. And so it behaves like a very large biomolecule. And as you can see, we compare different resin, the Nuvia HPQ and Nuvia Q, and the MacroPrep HPQ. You can see the Nuvia HPQ really have much higher binding capacity than the other 3 resin. And viral particle, as I mentioned earlier in the slide, the most challenging problem on the viral purification is this viral particle is so big. Even you have a large pore, the resin have a large pore, they may penetrate, but sometimes they are physically trapped inside the pore. Therefore, the recovery is a big issue. And one of the customers evaluate our resin, and they find they are able to increase the recovery by 15%. To summarize my presentation, the Nuvia HPQ is mechanically stable, and they are very rigid, so you are able to combine with the high binding capacity, the high rigidity, high pressure flow, you are able to increase your process productivity. And this resin is specifically designed for large biomolecule. And we have different format of product. For example, we have 25 ml up to 10 liter bottle, and we have a pipette column, 1 ml, 5 ml, and we have different small column also. For example, the 96 well place, including. Thank you for listening, and thank you for your time today. And you can find the application note and from the Bio-Rad website, or if you request the resin, you also can request it through the Bio-Rad website, and we have a lot of process specialists you can contact with to ask technical questions, and you can also email them.
Okay, so we have some questions for the audience. So how is Nuvia HPQ different from another anion exchange resin such as Nuvia Q?
The main difference between Nuvia Q and HPQ is Nuvia Q was developed for high binding capacity for most of the biomolecule. For example, the molecular weight is not that big as the large molecule. Therefore, the main difference between these two resins is one is open pore structure, one is the pore filled with the gel phase functional group. The gel phase really able to increase the binding capacity of the biomolecule, but we also find this gel phase will start to eliminate the mass transfer for this large biomolecule. That's why we improve our technology to develop a open pore Nuvia HPQ specific for large biomolecule.
Okay. And what will be the appropriate molecular size when using HPQ?
If you consider your current process, the binding capacity is not high, and you believe if it's due to the molecule, the pore size is too small, I will recommend you to use Nuvia HPQ. And if you consider your recovery is low, maybe because your biomolecule was checked and not able to recover from the resin, we also recommend you to use HPQ.
And what buffers can be used for cleaning sanitization?
As you can see in my presentation, we have been used 0.5 molar sodium hydroxide for 100 cycling study, and they have limited effect on the binding capacity. So we recommend 0.5 molar sodium hydroxide.
And how fast can your flow rate be without losing binding capacity compared to other resins?
Usually for large biomolecules, due to the low diffusion coefficient, so they are very sensitive to the pressure flow. When you increase the flow rate for this large biomolecule, the binding capacity often drop much more than the small molecule. But in order to reduce the drop on binding capacity, our resin is 50 micron beads, so this small beads will is easier for large biomolecule to get into the beads during the chromatography process.
Is this resin available in pre-packed process scale columns?
Yeah, they are available in the pre-packed column, and you are welcome to contact our process specialists. They can give you all the purchasing information, and as you can see on the slide.
Okay. So it looks like we have time for just one more question. If Jiali didn't get to your question, he will follow up after the presentation. So last question is, has this resin been used in a commercial setting?
Yeah, it has been successfully used for preclinical study on the IVIG purification.
Okay. So thank you, Jiali.
Thank you. Thank you for your time to listening the presentation.
The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Ask the Expert webcasts. So look for those announcements in your inbox. Thanks. Bye.
Bye. Thank you very much.